In this project, I will demonstrate how to use temperature and humidity sensor with FPB-RA0E1 board. For this project, I am using FPB-RA0E1 board and group base shield for Arduino interface and SHT31 temperature and humidity sensor. Now connect group base shield for Arduino interface on FPB-RA0E1 board, then connect STH sensor on any available I2C pins. I2C address for the sensor module is printed on the top side of sensor PCB. According to this quick start guide document, FPB board uses 914 and 913 as I2C pins. Open ESK Studio and create a new project by clicking on this file icon, then select Renesas C++, then select Renesas RA project. After that, a new dialog box will appear. You can give name to your project here. I am naming my project as temperature and humidity sensor. After that, click on next button. From this drop down menu, select FPB RA0E1 board. Then click on next button. Here select executable and no RTOS option. Then click on next button. Here select bare metal minimal and click on finish button. After project initialization, open FSP configuration file. Now click on stack tab, then click on new stack, then select I2C master stack. Now click on I2C master stack, then open properties window. Here change duty cycle to 50%. Here you can also set the slave address as 0x44. Then select pin for I2C master stack. Select 914 and 913 as I2C pins. Now we don't need to change anything further. Click on generate project content, then click on proceed button. Now IDE will generate source code related to FSP configuration file settings. Now open hallentry.c file. First of all, we need to declare these variables here. After that, you can define the address for SHT31 sensor. Now in Project Explorer tab, expand Developer Assistant tab, then expand I2C master stack. Now drag and drop I2C master open function call in hallentry.c file. Now declare FSP error variable and use assert function to make sure I2C open function call was successful. Now from Developer Assistant tab, drag and drop I2C master slave address set function call in hallentry.c file. Now you can use the ADDR variable here. Then type I2C master, then press Ctrl plus spacebar to get suggestion. Here use I2C master address as 7-bit. Now use assert function to make sure I2C master slave address set function call was successful. Now define this I2C command here. According to this datasheet, 0x2C06 command will enable single shot high repeatability measurement with clock stretching enable. According to this timing diagram, sensor will send 6 bytes. First 2 bytes will be temperature value, third one will be the CRC, and the fourth and fifth byte is for humidity value, and the sixth byte is again a CRC value. Now declare while one loop here. Now from Developer Assistant tab, drag and drop I2C master write function call in hallentry.c file. Now we can send the command according to sensor datasheet. Command size is 2 bytes and then set false for restart. Now use assert function to make sure I2C master write function call was successful. Now from Developer Assistant tab, drag and drop I2C master read function call in hallentry.c file. For destination buffer, you can use data underscore R variable. We want to read 6 data bytes from I2C sensor. For restart, use 0. Then use assert function to make sure I2C master read function call was successful. According to sensor datasheet, sensor will take 1 millisecond delay after responding to read command. Use RBSV software delay function call to introduce 1 millisecond delay. After I2C master read command, use 1 second delay. According to sensor datasheet, we can convert data byte into temperature and humidity value using these formulas. Now we need to write shift by 8 for first temperature byte and then a bitwise OR operation with the second data byte of temperature value. Repeat the same process for humidity, then convert humidity and temperature value according to the formula provided in datasheet. Now click on your project name, then click on this hammer icon to build your project. In FSV configuration file, we have defined the I2C callback function, but we are not using that in our hall-entry.c file. We need to define I2C callback function. For this, expand Developer Assistant tab and drag and drop I2C callback function in hall-entry.c file. Now again click on your project name, then click on hammer icon to build your project. Now right click on your project name, then select debug as, then select Renesas GDB hardware debugging. Now click on proceed button to switch to debug perspective. In debug perspective, open expression tab. In expression tab, add humidity and temperature value, then enable real-time update. Right click on variable name in expression window, then select enable real-time refresh. Now press the resume button twice. In expression window, you can observe that the every second humidity and temperature value are being refreshed. Now I am using a heat source near sensor to increase the temperature value. As you can observe in the expression window, temperature is increasing gradually and humidity is decreasing.